So another practice question here from the Australian Maths Competition 2013 paper for the intermediates, the grade 9s and 10s. In how many ways can the numbers 1, 2, 3, 4, 5, 6 be arranged in a row so that the product of any two adjacent numbers is even? Well, I guess that shouldn't be too hard to figure out. How do I ensure that a product is even? Product of two numbers is even if at least one of those numbers is even. The only way we can have a product that's odd is if we have odd and odd. So if we think about the 6 positions that the numbers could be in, look at my beautiful artistry there. I hope you're appreciating my skills. And I'm just going to use O and E for the odd and even numbers. So how are the different ways I could end up with making sure that each particular product remained even? Well, I could just alternate the odd and even numbers, and that would indeed give me one combination where every product, this would be even, the product of the first two, this would be even, that product would be even, this product would be even, this product would be even. And so every product of adjacent numbers would be even there. I could have had the same sequence, but in the reverse order, couldn't I? Even, odd, even, odd, even, odd. And I'm just going to speed up the process of putting them in their little positions there by doing all one long one there. Are there any other orders in which this could happen? And indeed there are. We've considered the case where O is at the front. Is there another way I could have it? Even odd ones first, certainly an even has to come second. If I put another even one here, I'm going to be forced to have two odds next to each other, am I? Or am I not? Can I avoid it? I could have even there, odd, even, odd. And here you can see no adjacent pair consists of two odd numbers, so I'm still okay. Finally, well, that's right, I was going to speed up the process, wasn't I? I could... Is there anywhere else I could place the odd one? So we did the odd one with the first and third. It worked if it was in the fourth. If I put it in the 5th position, is it going to work? Let's have a look. If I have an odd one there and an odd one there, where else could I put an odd one? Well, back here, isn't it? So we've already dealt with that one. What's the other way I could do it? Well, obviously I'm going to have even here. I could have an odd one. We've already done this so far. Now I want to change this order. What about if I went even, even, and then odd? And you can see that's just the reverse of the one I've got above, isn't it? It's just like the first two were the reverse of each other. That's the reverse of the one I've got above. That would be the only other way I could ensure that my odd numbers are all spaced appropriately. So that's good. I've got 4 different situations there. If I find the probability of each one and add them together, I'll have the right answer. Now, odd, odd, and odd. How many different ways could my odd numbers fill in those positions? Well, I could certainly have 3 different odd numbers that could go in the first spot. Once I've put an odd number in there, I've only got 2 odd numbers left to go in the second spot, which leaves just 1 to go in the third spot. Many of you will recognize that as 3 factorial. There are 3 times 2 times 1 different ways of having them in order. Same for the even numbers. I could have 3 different even numbers there, then 2, then 1. So for each of those combinations, 3 times 3 times 2 times 2 times 1 times 1, 9, by 2 is 18, by 2 is 36. When I look at the next possibility, the next arrangement, it's the same thing, isn't it? 3 by 2 by 1 for the even, 3 by 2 by 1 for the odd. That's going to be 36 different ways I could fill those positions with the numbers 1 to 6. The next combination also has 36 and 36 again. Why is it 36? If I look at just this last one, just one more refresher, the first odd position, there are 3 numbers, 1, 3, or 5 that could go in there. Once I place one of them in there, there's only 2 numbers that could go in that third position, which leaves 1 odd number to go in the last position. Even numbers, same principle. 3 possible even numbers could go first, the 2, or the 4, or the 6. Then I've only got 2 left. Once I've placed one there, I've only got 2 left to go in the even position, and 1 left over at the end. 4 times 36, 120 plus 24, 144. The answer's D. Hope that helps. Catch you in the next one.